Welcome, students, to Reflections, Part 1. And what we're going to do, first of all, what do we mean by a reflection? What a reflection would be is, let's say you had, I don't know, it's easier for me to draw, so I'm going to go with the square root function here. Say you had this guy. If you wanted to reflect it across the x-axis, okay, this is your x-axis here, that means that your reflection would be down here like this, okay? It just beams it across, like it's spun across, and the central core is the x-axis. So that would be, this is reflecting across the x-axis, okay? Reflecting across the x-axis. Now suppose you want to reflect it across the y-axis. Then your central core is the y-axis. And it's kind of like you got this little function here and you just rotate it over. It's like it just flips right across. So it's going to be something like that. So this is a reflection across the y-axis. Oops. All right, so that's just to set the stage so you kind of know which way the reflections are going. Now, how do we make that happen? Why don't we stick with the square root function here? What changes do we make to the function? So here's our original function. Let's say we want to do the reflecting across the x-axis. Reflect across the x-axis. What change is going to make that happen? Well, let me explain the reasoning behind it. If you look at the points on the original, like 1, 1 or 4, 2, you don't want to change how far you've moved to the right. In fact, we want to move to the right. What we want to change is we just want to change the y value. So let's take this point here as a real good example. This is the original point. Okay, this is the old point. Where do we want that guy to go? It's up here right now. We really just want to beam it across down to here. Okay, and how we do that is, so the new would be, we want to keep the x's exactly the same. We just want to take the y value and change the sign on the y value is really what we want to do. And that would have the effect of taking 4 and up 2, and now going 4 and down 2. So that's exactly what we want to do. So you really want to just take your y's, and you want to put a negative sign in front of them. And you want to keep all the rest the same. Okay? Now you'll notice that it's kind of funny. Everything as far as transformations goes, it's almost like you always do things a little backwards. If you want to reflect across the x-axis, then you find the y and put a negative in front of it. So you can guess where this is going as far as flipping across the y-axis, but we'll get to that in a moment. Let me just show you one other way I could write this. I could multiply both sides by -1 and have the negative show up on the right side. Often that is the case. You'll see it written in this explicit form. So just be aware of that. Sometimes they'll do that. And also be aware that this is not putting the negative in front of the x. This is putting it in front of the entire function, and there's a big difference there. So let's actually now let's have a look at what if we do want to reflect across the y-axis. Okay, so let me just clear the screen here, and I kind of like having that original graph there. Okay, so there's the original graph, y equals root x, and we really wanted to now flip it this way, right? This is what we want to do, flipping it or reflecting across the y-axis. Okay, well you probably already guessed what the secret is. You take your function, and if you want to flip it across the y-axis, you got to locate x, and it's inside the function. So that's the difference. Before that negative was sitting out here. Now what we want to do is put the negative right in front of the x. That should have the effect of flipping or reflecting our original across the y-axis. Now, why is that? Again, let's look at a point. I didn't exactly draw these that well, but let's just say that was the point 4, 2. What's the new location of that point when it reflects over to here? Well, this should be negative 4, 2. Okay. In other words, we want to take the x's and put a negative in front of those x's, and that's what's going to beam things across. So that's kind of the sort of seeing the big picture as to why that works. Okay, well that is the rule, and I think maybe we don't want to drag this out too long. Let's stop with the rules and we'll come back with a couple of examples, and then I think we're probably good to go. So we'll stop there for now.